We will be deriving the equations for elliptic curve, point addition, and doubling. So given two distinct points on an elliptic curve, P and Q, and a line joining them, let x3, y3 be the third intersection point of the curve with the line. Then the addition of those 2 points is defined as R is equal to P plus Q is equal to x3 minus y3, given the symmetry across the x-axis. And given P is any point on an elliptic curve with tangent line to curve at P, let x3, y3 be the intersection point of the curve with the line. Then point doubling is defined as R is equal to P plus P is equal to 2P is equal to x3 minus y3. Same thing given the symmetry across the x-axis. So this is the equation of the line L. Y is equal Sx plus M. And this is the equation of the elliptic curve. Y squared is equal x cubed plus ax plus b. And we need to find the intersection points by setting L is equal to E. So Sx plus M squared is equal to x cubed plus ax plus b. And we flip those around, so we get x cubed plus ax plus b, and we expand this one, so we end up with this, and we end up with this equation. So we have 3 intersection points, which means we will have a cubic equation with 3 solutions. So x minus x1 multiplied by x minus x2 multiplied by x minus x3 is equal to 0. So we'll multiply those two, we get this, and we're multiplying by x minus x3 is equal to 0, and we rearrange those, we get this, and then we multiply x squared by x. This gives us x cubed, and x squared by minus x3 here, etc., and we end up with this equation. So we have those two equations that we just derived, this one and this one, and we match the coefficient. So for x squared we have those two coefficients, s squared, the slope squared, and x1 plus x2 plus x3. So those two must be equal, and this means that x3 is equal to s squared minus x1 minus x2. And from here the x for the r is equal to x3, so for the addition of those 2 points, and the y is equal to minus y3. So xr is equal to s squared minus x1 minus x2. And we want the slope of the line passing through x1, y1 and x3, y3. So s is equal to y3 minus y1 over x3 minus x1. So we end up with minus y3 is equal to s times x1 minus x3 minus y. This should be y1. So also we have that yr is equal to minus y3. This means that yr is equal to s times x1 minus x3 3 minus y1. So this is the slope in the case we are doing point addition. So s is equal to y2 minus y1 over x2 minus x1. So x1 y1 is p and x2 y2 is q. And in the case of point doubling, we take the derivative to find the slope of the tangent line at x1 y1 here at p. And this is the equation of the elliptic curve. Y squared is equal to x cubed plus ax plus b. So 2y dy is equal to 3x squared plus a dx. So dy over dx is equal to 3x squared plus a over 2y. So this is the slope when we are doing point doubling. So we end up with those equations for elliptic curve point addition, xr, and this is r here, xr, yr. So xr is equal to s squared minus x1 minus x2. This is x1 y1 and x2 y2. And yr is equal to the slope times x1 minus xr from here minus y1. And the slope is equal to y2 minus y1 over x2 minus x1. And the slope is the slope of the line through P and Q. And for elliptic curve point doubling, xr is equal to s squared minus 2x1, since x1 is equal to x2 here. We only have 1 point. So s squared minus 2x1. And yr is equal to s times x1 minus xr minus y1, same as here. And the slope is different, we just derived it here. So it's 3x squared plus a over 2y1, and this is the slope of the tangent line through p x1 y1, which is the same here as q x2 y2.